I have some free time now. Okay, so uh, all right. So let's again write some example, right? We have already written, so I'm creating a temp. I will delete this package. All right. So in the last session, what we have done is, let's suppose runner. There was a runner task, right? So there was two tasks that I wanted to execute, right? One task was to print hello, or print 1 to 5, right? And the second task was print hello 5 times, right? These both tasks are independent to each other, right? We don't need to know which count right now is present, then we print the name, right? Or hello, yeah, hello 5 times also good, no worries. So how we can achieve this thing is, if I'll just simply write one for loop and then plus one also, and this code will print 1 to 5, very basic one, right? 1 to 5. Now print hello 5 times, same thing we can do again, but in this time we'll do hello. If we run this, hello and hello and counting is printed, right? And what if we want to give a break while printing the data, right? So we know that thread.sleep, make sure that the current thread is fallen asleep. So we want 1000, so it takes the values in milliseconds. We have talked about the milliseconds. It's 10 to the power minus 3, right? So 1 second will have 1000 milliseconds, right? So this is 1 second. So let's take 2 seconds. The code will work for 2 seconds and it will going to throw an exception, right? Interrupted exception. But this is not a exception handling session, so what I'm going to do, two things we can do: simply throws, right? Where we don't want to handle the throws exception, we can do, but I don't use this because it looks little bit cool if we use this sneaky throws, right? But we never have to use this sneaky throws in the production environment, right? So now if we run, so after 2 seconds one value will print it, then 2, then 3, after 2 seconds, then after 2 seconds 4 will print it. So this thing will go on, right? But once, all right, so we have made sure that we are waiting only in the printing task, right? So let me add this thing in here as well, right? And let's do one thing, right? Yeah, so let's run it again. Now the thing is, because these both tasks are independent, printing the well counts and printing the hello, it's not dependent on each other. So why to wait for printing count task to get complete and then start printing hello, right? It does not make sense. Like if I want to create the data of flight results from Air Asia and Indigo, then I should not wait for the Air Asia result to ask for the flight details from Indigo, right? Or the vice versa. I should not wait for the Indigo flight result, and then if Indigo flight results, if the Indigo provide the result of their flight, then I'm going to ask for flight result from Delhi to Goa from Air Asia. This thing does not make sense because those tasks are independent, right? The end user is waiting for the result from Delhi to Goa, so they cannot wait. I mean, the user is not going to wait for 10 to 15 seconds, and especially if they are going to hit multiple airlines, 15 to 20 airlines, then it does not make sense to make sure to wait uh, the people. And then down there are different scenarios how company deal with this usually. But we are not going to dive deep into this. You can read about it. Some companies prefer, if anyone provides us the result, we will populate and show it, and then later on if the results keeps on coming, we will update the data. So this is also one technique that usually companies follow to make sure their latency is less. All right, so now our task is to divide these things, right? Okay, this thing is going to take, to print the index is going to, or the value will going to take 2 seconds, right? We know it. So if we cannot do anything with it, but because AirAsia is not our company's API, right? So we cannot do anything with the AirAsia API. Similarly, we cannot do anything with the timing that we are getting the data, right? So we cannot do anything with the duration of this thing. What we can work with is the way we are trying to fetch the details. So what I want these two things to execute parallelly. As the oops in the oops, Java follows the waterfall pattern, and what it is, it's going to execute line by line, right? But I don't want it. I want these lines to be parallelly executed with these lines. So the concept of threads comes into existence for this. Now for the thread, if I want to make sure that these two tasks run separately and in a thread, then there are two ways. One is by extending the thread class, another is by implementing the runnable, right? So the better one is implementing runnable. So uh, print print count, let's call it count task, let's call it count task, and implements runnable. So now we will copy paste this thing right later on. So the thing is, we already know if we are trying to implement interface, then we need to, and we want to make our class a class, not an abstract class, a concrete class, then we need to implement the abstract methods, and it has one abstract method with the name run, right? So we are going to implement it and just simple copy paste, right? And then the another task is print hello. Okay, my bad. So hello task. So same thing we are going to do, implements runnable, and then we're going to override the method run and simply paste the task, right? All right, over here sneaky throws, it's just to suppress the error. All right, and counting task at the rate sneaky throws 2. Now I want another runner, thread runner psv. All right, now the thing is, we okay, so if I want this things, this code and this code to run parallelly, so I need to start a thread, right? Without a thread object I cannot do it. So eventually we know that we need to create a thread object. So there are two tasks, hello count task and hello task or count task. So what I'm going to do, I need to create two threads, right? First we can create the object of this count task equals to new count task, and then I need a thread object. If I want to work with the multi-threading, the thread objects needs to be there, and thread dot start, right? In the later parts in Java 5 and 8, we don't need now this to create our object of threads. Internally it will handle everything, we don't have to get involved in these things. Why? Then we will read about it. So but the thing is, it's still people ask these questions, and still people sometimes write this code in this manner, but it is obsolete even from 2009, the way that we are writing right now. But still we need to learn it because internally this thing happens, right, whenever we write the upper level code. Cool. So coming back to this, so this is the task that is going to get executed. It has the run method, right? In the run method we have the for loop which will print the values from 1 to 5. To run it in parallel, I need to create a thread object, and once a thread object starts, it will start parallel execution, right? Two processes will start. One will follow the waterfall model, and another thread will start which will start counting the numbers. Then hello task object, I can create a hello task object, hello task, and then again, because we need thread, right? Hello task thread, new thread, and okay, hello task, we want the constructor needs the runnable. See, this is the constructor of runnable, right? So now I will do hello task. What happens when I do the start? As soon as I call the start method internally in Java, will call the run method of the task that has been submitted. And what we are calling task? We are calling task object of runnable, right? So now if I start this thing, what will happen? The flow control will come at line number 6. Then the object will create it, right? Then a thread will be created, and then the run method of the task will start execution parallelly. There will be one execution flow that will execute parallelly, and another flow will come to line 9 and line 12. As soon as it reaches to line 12, another object of task will be created, then a thread with that task will be created, and then again parallelly this line will going to execute, and this method will end. Main method will end, and the rest, these two thread will be working, still working. Let's see the execution. 1 and hello, right? 2 and hello. Parallelly execution has started, right? Visual.
Yeah.
Process ended. So this is the one thing that we have seen in the last session, but usually but the thread, we have directly seen the thread, right? And how it start and all those things. But we can go around it a little bit more, just to make sure you are a little bit more adjusted, or you are able to see things now. So in the basics, we are already in the basics. Okay. Yes, it should be included in basics, ways to create thread. Okay, but basics, and again basics. Okay, I should create another package. Okay, in the basics, itself is basic, so okay, fun to know. All right, or let's say knowledge bits. Cool. Now let's just play a little bit with the threads, right? So thread task. Okay, thread name, right? Okay, a runner. I wanted to know, see, many times in the sessions you must have seen me saying that this main method is run by main thread, right? And main thread is a part of main thread group, right? Okay, if you don't remember, you can even go through the videos again. Multiple times I have mentioned this. So today we're going to see whether it's true or not, right? So this line will get executed, right? Okay, let tell me one thing. Is Java requires multi-threading? We in the last session had the conversation that the games requires multi-threading, right? We have taken the example of Mario NFS, right?
Right. Yeah.
Okay, and these was the games that was created in the 90s. In today's era, the things are entirely different, right? We have talked about that also, the course and all those things. So the course peak. So the thing is, do we need the same thing with the Java also or not? The Java needs multi-threading for execution or not?
Yes.
Okay, can you give me example why?
Garbage collection.
Great. Who answered this? Ashok.
Yeah. Sure. Kishore.
Okay, Kishore. Cool. Okay. All right. Nice. Great. Anything else? What is a garbage collector?
It collects the unreferenced objects which are on heap.
Yes. Okay. No. What? Okay. Cool. Which paradigm is of Java language? If I create a student object, right? A student. If I want to an object of student, how I'm going to write it? All right. We have less.
Class.
Okay.
Right.
Yes. Right. So we have less time. So let's do one thing. I wanted to know what is a garbage collector, right? Garbage collector in the padding of oops is a object, right? And how can I create an object? I can create an object from a class, right? Because class is a blueprint out of which I can create n number of objects, right? Like we can have a blueprint of a house, and the similar house we can create multiple times if we have the material, right, to build the
Okay.
house, or the land with the land. So land would be the memory and the material would be the values that you are providing. This is an analogy. All right, cool. Let's move ahead. So now the thing is, your garbage collector needs to run parallelly, right, to collect the garbage. So that's why you need the thread. But garbage is an object, and someone needs, and to create an object we need a class. So someone needs to load the class, right, so that its object can be created, and then that object will keep on running parallelly, right? So the class loaders is required, right?
Okay. Okay.
So there are n number of things, right? The output also we see, right, in over here. While our code is running, we are seeing the output as well, right? For example, okay, the normal task is not here. Temp, inside temp, when I run a task, okay, run a task. Yeah, when I am running this thing, now in the console also it's printing, right, the values, and it's processing also. So one thread must be there, right, to pass the values to the console. And for us it's the screen right now for mine, right?
Yeah.
Okay.
Java itself to run needs multi-threading. Okay, so again, let's, okay, coming back to what, okay, basics and okay, knowledge bits, cool. So I wanted to know, right, because I know before execution of this line, multiple threads has already been created, right? It is stored in groups, and not going to dive deep into that because it's not required in your entire life. You're not going to work with this thing, right? It's just basic knowledge bits. So the thing is, I wanted to know which thread is executing this line, right? There can be a number of thread, right? So I wanted to know, okay, just give me 1 second. 1 sec. Okay, so let's start again. Where were we? Oh, okay, all right. So we wanted to know, because we already know that there are multiple threads, right, that's running before this execution, before the control comes as a line number 6, right? So multiple threads are required, and garbage collector will already be up, right, till this time. So I wanted to know which thread is executing this, right? Out of many threads that exist in the system right now, which thread is executing line number 7? Because this will be the thing when you are going to write the threads in multi-threading environment. You sometimes need to know which thread is executing the code. There will be, I mean, we'll see in the entire course, we'll see the thread naming and all those things, but in the real time also, if you want to process parallelly, then we wanted to know, because debugging is also an issue, and the logging, debugging, exception handling with the multi-threading is also a criteria, right? We're not going to cover those things in our course, right, in this time. The thing is, otherwise it's going to take a month just for the multi-threading. All right, so right now I wanted to know which thread is executing line number 7, right? So there is a class, thread class, right? Thread is a class in Java in which I can say the current thread. The current thread will bring the thread which will refer to the thread which is executing the line number 7, right? And then I want to get its name, right? So what I'm going to do, I'm going to print it simply. All right. So what I usually say, there is a main thread group, and main thread group has a main thread, and the main thread executes starts executing the main thread, right? So the name of this thread, right? So the name of this thread should be main, right? Main thread group has a main thread, and the main thread is responsible to execute the main method, right? So the main is the thing. So if we run this, thread name main, right? The thread that's executing line number 7 is main, right? Visible?
Yeah. Yeah.
All right, then the other thing comes, what about the thread group, right? I have mentioned thread group also, so no worries. Same thing we're going to do right now, thread, right, dot current thread. This will give us the thread that is executing the line number 7. Then I want the thread group, right? In the thread group, if we go, it's already in the toString, it's already the thread group name, the priority, okay, and the group name, thread name, priority, and the group name. So I'll print it too. So group details plus thread group details. Cool. Now let's run this. Nobody's going to ask these questions, right? There might be a chance that someone will ask you which thread get execute the main method. That's it. Thread group usually asks in the OCJP if you want to get certified for the Java, and that's why I know also. So the thread group details are name. Thread group name is main. Thread group max priority. Yeah, max priority 10. Not good. I wanted more data. And why thread group toString. Okay, the name and the max priority. All right. Okay, threads also give me threads. Okay, name of the thread group. Okay, so the name of the so the details over here is the main name of the thread group, right? So the name of the thread group is main, and that contains the main method, main thread, right? So what I'm going to do, I'm going to print all the thread that exists in the thread group. So what I'm going to do is simply thread dot current thread dot thread group and dot get. Okay, it's refusing to give me threads. Why? Okay, it's default, it's not public. Is there a way that they can give me the name? Okay, there is no getter. Parent thread group. Okay, thread enumerate. Alright, no. Alright, cool. I mean, no worries. It's, I mean, we can do this, but it's then there are different things that in which we can do, but right now we need to go through other concepts as well to use it. But now you can see just one thing, that okay, there is a main thread group, right? There's a main thread group, and which has a main thread, right? The thread that is executing this line is main, and it's a part of which thread group? Main also, right? So the main thread group has a main thread which executes the main method, right? A static main method of Java. Clear till now?
Yeah.
All right, so the thing is now, can we change the name? So let's change the name of this thing and make it thread name and thread group runner and main method. All right, so the next thing that we're going to see is thread name setter and getter. Okay, all right, so the same thing we are going to do. So the thing right now is, we already have a thread, right? We have written the temp, or let's create a thread. Let's create right over here. Let's create a thread, and let's say any task, right? Count task. Okay, and okay, before this we can use the same thread also, right? This thing we have already seen that, okay, thread dot current thread dot get name. This will provide us the name of the thread, right? We have already seen this, right? And what will be the result if I assess out this? Okay, my bad. What will be the result?
Main.
Yes, this will be the main, right? But if I get the current thread, and the current thread provides an object of thread itself, right? So if I hold, I know it's the main thread, right? So thread not current thread, I know it's the main thread, right? And what I can do, I can do the main thread get name as well. It will be same, right? Thread dot current thread, and this is same. If I replace this with this, it's same, right? If I run this, okay, multiple times the same thing. Okay, if I run this, the output will be same, right? Main thread, main. So thread name. So thread name is main right now. If I run this again, thread name is main, right? So let's do one thing. The main thread. So there is a set name also, right? So let's say I don't want it to be the main thread. I want it to be something else, right? So I want the thread name to be okay, let's say Kishore thread. Cool. And then again, if I want to fetch the name of the thread, same lines, the lines that we are using above, we can get the same lines, right? Copy and then paste. If I run this, earlier it was main thread, and the same lines I have used, right, in the line number 13 as well. Over here is the Kishore thread. So we can set the name of the thread and we can get the name of the thread, right? Setter and getter for the thread names are present. Clear till now?
Yeah.
Nothing new, nothing great. Cool. So now there is another thing with the threads as well, is thread priority. So there are a lot of things with the thread priority. So usually the interview question goes around. We are not going to cover this in this course, but the question is like, these are the for senior software engineer or the tech leads usually, and the question is, if when a thread is starving, when there are multiple threads and one is starving, then how can you make sure that no starvation happens? Which design pattern you will try to follow? So if this question happens, then we need to work with the priority. So the thing is, every thread should have a priority, right? So now we know that, okay, this is how we are going to get the current thread, right? And our current thread is the main thread. Main thread. Okay. Main thread and thread dot current thread equals to cool. So I want to know the priority, right? So I know it's the main thread, right? Thread name plus main thread dot get name, right? And one more data plus has priority. Cool. Has a priority of, then main thread got get priority. Cool. So this, the priority is, the thread name is main and has the priority of 5, right? Now the thing comes into our mind, what is the priority and what is the 5 priority, what is the range of the priority, right? Multiple questions we get in our brain, right? As soon as we see that, okay, the priority of the main thread is 5. So one thing is, what is the range of priority, right? The other thing that we see, okay, how the priority, how to assess the priority, now the thing is, what does this mean? This means is, if let's suppose the range is from 1 to 1000, right? Then is 999 has higher priority, priority or 1 has higher priority, right? And why this thing? Because if we see the rankings, right, less rankings means the greater ranking, right? Because if you score AIR 1, then you are the topper of the country, right? All India ranking 1. So the less means top. But if you want something else, if you want how many kilometers you have run, or you have driven, or you have walked, then the more that you have walked will be the higher, right? Will count higher. That's how we are going to assess whether the less means more or more means more, right? Quantitative numbers. The race, whoever is going to complete in the less number of duration of time will win, right? So that's the thing how we are going to assess the priority. So the thing is the range is 1 to 10, right? And then this 5, we know that this thing is 5, right? The priority of the main method is 5, so the default must be 5, right? But it does not give any idea whether the 1 is top or the 10 is top, right? I'm audible?
Yeah.
So what we can do is we can simply see max thread priority, max thread priority. So it's very simple, just it's max priority, right? And the same is going to be the okay max thread priority. Let me just put a space. So min thread priority, right? I'm just going to change it to the min, right? If we run it now we know the max priority is 10 and the min priority is 1. That means it follows the usual course. The higher the more weightage it has, right? Clear? But what about is, do we have something else as well? Norm priority. Normal priority will be the 5, which is of okay, my bad, let me write normal priority, norm priority. So the norm priority is 5, min priority is 1, and the max priority is 10, right? So our main thread which start execution of our main method has the norm priority, right?
Yeah.
All right, so now comes the interview question. So interview question regarding thread priority. So it's, we know these priority, right? So now we know child thread priority runner. Okay, but I want multiple classes because you don't know how to. Okay, so package is required. Cool. So now but why? Don't need. I can create a common thread that I can use, right? So instead of putting model somewhere else, I can put a model over here. Alright, over here let's write a thread. So counting task, let's create a thread of counting task itself, and implements runnable, and then we are going to override the method and just count from 1 to 10. Alright, and then for int I less than 5 I plus plus, and sys out I plus 1. And after this I want to wait for 2 seconds as well, so 2 seconds in the millisecond, that's why 2000. Sneaky throws never used in the production, it's just to make sure we are not suppressing the force, we are suppressing the force compile time exception handling. Alright, by using the sneaky throws that we should not do ever in the production. So now we have a common counting task. So in the interview part, now I can write this basic item, child thread priority runner. So now we know one thing, that there is a main thread, right? This thing we already know, right? We have seen multiple times now. So this thread which is a main thread, so the thread name, main thread dot get name, my bad, get name has priority main thread dot priority. Cool, we know that the output will be main and 5, right? We have already seen this. but what if I'm going to create another thread child thread? Why child thread? Because who is going to execute line number 11? Which thread is going to execute line number 12, 11? Which thread is going to execute line number 13, 14? I'm audible? Hello? Hello? I'm audible?
Yeah, main thread.
Yeah.
Okay, main thread will execute, right?
Yeah.
And we are creating a thread object, right? And who is creating the thread object? The main thread right now, right?
Yeah.
Okay, cool. So the thing is, now we will see if, okay, I don't even have to start the thread. We'll see that later on. Now if I'll say the child thread also I have right now, right? So the same thing I'm going to do that I have done with the main thread, right? But I'm going to just replace with the main thread the child thread, right? So now we haven't set any priority, right? What will be the output? The output for the above line number 10 we already know, right? We have seen multiple times now. But what will be the output for the line number 16?
Same 5.
Why 5?
Default priority.
Okay. Anyone else? And what about the name? Okay, cool. The default thread name will be thread 0, right? And the default priority will be 5 right now, right? Thread 0 and 5. If I create another thread now in this line, then the next thread name will be thread 1. If I just copy paste this again over here, child thread 1, right? And I already have a counting task, so child thread 1 and the child thread 1, right? If I run this now, first one was thread 0, another one was thread 1, right? So it will keep on changing, right? And the thing with the thread priority is not the normal priority. What if why I made its child thread, right? If the main thread if the main thread priority I change, priorities can also be changed, right? I made it 8, right? So let's see. Okay, again if I print the priority, so if I run the code now, you will see the main thread priority was 5 earlier, right? Then it has been updated to 8, right? Visible?
Yeah.
So now if I uncomment the code again, what will be the thread priority, child class priorities? Is still 5 the normal priority, or you want to change your answer? Alright, so let's run this. This is an interview question. The output is 8. That's why it's child, right? Otherwise it's a normal thread. Why we calling it child? So the thread priority will get, the child will get its parent priority. If the parent priority is 8, then the child will get 8. If the parent priority is 5, then the child will get 5. The default priority, there is no default priority, right? It's called the normal priority. In the thread class, if you go also and try to check the norm, okay, bad, I need to go up again. It's the normal priority, right? Minimum priority, maximum priority, normal priority. There is nothing like the default priority. It's normal priority is why? Because it's in the mid. Cool. So there is no default priority concept in the thread. It's the child and parent concepts are there. So the child thread will get the priority of its parent, right? Because our main thread is of 5 priority. That's why if we don't change the priority of any thread, then all the threads that we are going to create will be of priority 5 itself, right? That's why some people think that every thread is running priority 5, but that does not happen. Cool. This is an interview question, right? So the interview question is not about the thread number and priority, what's the min and max. The interview question will be what will be the priority of a child thread. All right. So this is child thread priority, right? This was an interview question. Cool. And everything else was just for seeing the data. All right. So coming back to our knowledge bits, what else we can see? Okay, thread group.
Abhishek.
Yeah.
So the main thread is the parent thread for all other threads that we create?
Yes.
Okay.
Because eventually we'll start from here itself, right? Then we can fork it again into multiple things. Even
Yeah.
even if you want to start a microservice or a standalone application or a single class in Java, right? If you want to write a single class, this is a single class, right? Execution. Everything starts from the main method itself, and you cannot, and no one can directly call the main method. We think we directly call the main method by running this, but this does not happen. Behind the scenes, a lot of thing happens. Then eventually, the main thread group has a main thread which start execution now, which start executing the main method, right? So this is how thing goes. Before that, what happens, if you are interested, you can go ahead and learn about the JVMs and their internal. But I won't say it right now. If you are free, then it's cool. If you want to switch job and those, then do those things. Then there are other things that has more priority, right? Because nobody's are going to ask you how it internally works. All right, then and it might be little hard for you to understand right now as well, because once you are good with the generics and all those design patterns and all of those things, then it becomes easy and cool. So clear till now, right?
Yeah, yeah.
All right, so now we can directly move. So these things I just made sure to cover to make now the thread will look little bit more workable. So thread priority, okay. Now the ways to create thread.
Yeah,
Explain.
Abhishek, you are mentioning about that contention to prevent the starvation.
Yes.
Um, I mean, how to prevent just a rough idea can you give?
Oh, okay. Okay, cool. So again, okay. See, it is interesting question and interesting topic. So, but the thing is, it takes a lot of. Okay, in short, I'll try to cover in short, right? Why starvation happens?
Right.
First thing, cause the thread has a priority, right? Now we know that the max priority will be 10, right? And the min is 1. Let's suppose I receive my processor is very slow. It can take a single task, right? It can only take a single task at a time. Cool. So let's suppose I get 2 tasks at a time, 10 and 5. Cool. Visible? So my processor can take only one task, and which task is of the highest priority?
10.
10. So 10 will be taken out, right? So after us, and if it takes 1 second to execute one task, then it will take 10, right? Then only 5 is left, right? But in the next second, before it again try to see which value to execute, it's going to see another task comes, right, of 9 value. Now
Okay.
which will get executed? 9, right? In the same manner, let's say in the next second another task comes with the 8 priority. Then in the next part another task comes again with the 10 priority, right? These things keep on happening for 2 hours, right? So this thread will starve, right? This is called starvation. You're not getting food, right? And you're not getting the processor, right? Over here it's not the processor. In humans we call it when we don't get food. Usually we can starve for the multiple things, but usually it's for food. So now the thing is how I can make sure that this does not happen. The thing is I can set the timer that okay, if this thread has waited for 10 minutes, then after 10 minutes what I'm going to do, let's suppose this is a single second, what I can do that after a single second, if my thread does not execute, then I will increase its priority. So after 1 second I'll make it 6. Then after 1 second, I'm audible?
Siri here.
Oh,
Let me know if I can help.
wait. I'm audible? Hello?
Yeah.
Yeah, yeah.
Okay, Siri got activated somehow. Alright. So after 1 second, I'll update the value, right? Its value to 6. Then another second, it does not get executed. I'm going to again update its value to 7. Cool. Then again, it does not happen, right? Then I will again update this value to 8. Now let's suppose after this thing, a value of 8 comes, right? Now because it does not execute here also, now its value will become 9, right? Now its value become 9, right? So
Yeah,
this will execute now. So this thread does not get stopped, right? So this is how we implement it. This is one thing, right? Now one can say, all right, instead of just 1, every time 10 is coming, then what will you are going to do? Then again you'll say, okay, I'll try to set the date as well, right, when the task has been submitted. Cool. Then there can be a thing, because now we work with a multi-threaded environment. Then one can say, okay, your task was scheduled, your task get the processor, and it's of max priority, everyone is of max priority, and your task also get the processor, but somehow that processor does not able to comply or work with, right? It gets switched off or broken or anything. Then how it's going to execute, right? I mean, you have submitted the task, right? You have submitted a task, and that core burns or something happens with the core, right? And it's not able to process your code. So then what will happen to your task? It will come again to the scheduler. We'll see in a while what is a scheduler and all those things. It will come back to the scheduler, and then how your scheduler will going to work with it. Okay, and then from there design pattern more question starts. So this is also a design pattern which I have already told you, right? To increase the thread priority so
sure.
that it don't
Okay.
stop. It's a design pattern of thread. So there are multiple design pattern, and I mean there are 2-3 design pattern which will eventually solve these questions that they will ask you eventually. And these all things is not possible by synchronized in those things, right? And these things are not even possible in all the languages, because all languages does not provide the support Java is providing for multi-threading. And also these things was not possible till Java 1.5. Okay, let me just cross check it, right? Because there might be a chance. If you say it to someone, then okay, yeah, till 2009. After 2009, you can solve these things, but before 2009, you cannot solve these things, right? You cannot make sure your thread don't stop. After 2009, you can write the code so that your thread
Okay.
won't stop. All right, so all right, let's end this because we are at the very basic stage right now. Okay, so the main thread. Okay, all right. Just 1 sec. Okay, cool. Yes. Coming back to the interview questions of the thread. All right. So implementing and this runnable model. Why we have model here? If we have model outside. All right, we don't have model outside. Okay. Ways to create a thread should not have a model. Model should be outside in temp. Let's delete the temp. Now temp does not make sense. Interview makes sense. This and abstract counting processor. Okay, abstract counting processor. Okay, this is also a helper class, right? Let me check if I'm using it. Okay, I'm already using it, so it should be in model itself. Why it's outside the model? Knowledge bits, ways to create basics can have a model. Basics can have a model. And all right, ways to thread don't need a model. Okay, but it has count task. So abstract processor should be inside the model itself. And which model? This is also count task. This is empty count task. Cool. So let's counting task. Let's delete this count task. Okay, let me check whether I'm using it somewhere else. Okay, no one is using count task, so I can move this model to here. Now it's better, right? Now h2 thread has only extends, implement, and then integrations. Cool. So we need to see how it internally works. Okay, right, let me open the nodes now. Let's start it. Cool. Okay, see, this thing we have already covered. Okay, why we need thread, why. Okay, so this is the things that we have done with the main thread, right? Current thread, current thread, right? Information about the main thread. The thread is running immediately. The thread is the main thread. Okay, it uses new thread. Alright, same thing. Single thread model. Alright, single thread model, right? This is the single thread model because main thread is doing execution, right? Every execution is done by normal things. And developing games, animation, multimedia, we have already done this. A thread interface, we have already done this. Multiple approach. First approach we have already seen. Flow of execution, yeah, great. This thing we can do now. All right, so see how the code, this thing, okay, we have already created the code for the counting. Okay, okay, today we have created, but I have deleted that code. Okay, all right, okay, but flow is important. So let's flow of thread. Let's set it over here. So flow we have already created. Don't need to create over here with the thread implement runnable. We can have, yeah, cool. So see, instead of doing the multiple tasks, let's have a single task, right? It makes sure. Okay. Counting task M1. All right. This is an integration. Okay, cool. So what will be the output of this code if I try to run this? I'm audible?
Yeah.
Okay, what will be the output of this thing? The counting task will count from 1 to 5 in the entire multithreading classes.
Yeah, so 1 to 5 will be printed.
Yes, nice. Okay, hello user. Counting task is printing hello user. Okay, cool. No, okay, my bad. So I think I have in greeting task is counting then. All right. Okay, my bad. I have swapped the code. I have to swap the code. Cool. So the greeting task is now right over here is this one, right? Now if I run this, now it will be better. See, 1 2 3 4 5, right? After some seconds, most probably 2 seconds, right? Yes. So this is the flow right now, but which thread is executing these lines? Which thread is executing these lines? You know the answer. We have covered this, right?
The child.
Come again.
The child task thread.
And how, and see it's easy. How can I know that which class is writing this? Same thing, right? I will just simply, okay, my bad, I've changed the code. I need to put it here in the braces I, and just to make sure which thread is executing these lines, I'll do the thread dot current thread dot get name, right? Now I will get the thread name, right? So if I run this, and also let's do one thing, let's see which thread is okay. So thread dot current thread dot get name here, obviously it will be main thread, right? So it starts execution. Cool. And then it ends execution as well. Now two questions are there. What will the output of this line?
Main thread.
And what will be the output of this line?
Same main thread.
Yes. And inside this, what will be the output of this line?
Thread 0.
Yes. All right. And when will this line gets end? Will it wait for the entire counting task to get complete, or it will end earlier?
It won't wait.
Yes, it won't wait. Why it won't wait? We are going to cover this now. See, main thread starts and its execution ends, right? And the thread 0 is executing still, right? Now it ends. Visible?
Yeah.
Alright, cool. Now we'll see how it usually works. Right now, the very first line, right? Main thread group will have the main thread will run the main method. So line number 9 will be executed by main thread, right? So main thread has started its execution. Then I'm creating a task which will is a runnable object. Then I am creating a thread class and providing the task for the thread, right? Then I am calling the start method, right? What with the start method? See, now we know two things. One process will go normally, right? Because this will be the main thread, and another thread is thread 0 right now because we haven't provided any name. So the main thread has these 5 lines. That's it. This is its responsibility. And this main thread, the code inside this main thread, which has the this counting task, this code is not this responsibility because it's execution. The execution is happening parallelly, right? So, but how it's happening parallelly? Why it's not the execution is not done normally? Why it's happening parallelly? The reason is when a when will this threads will run, right? As soon as the CPU will provide it to them, right? I'm audible?
Yeah.
All right. And there will be multiple threads, right? There will be multiple threads already present in the system, right? So main is already there. I have created created one more thread that was already there. So how will CPU will be shared, right? This thread can start its execution as soon as the CPU is provided to it, right? But how will the CPU provide it to it, right? First thing, how to know whether it's a thread or not, right? If it's a thread, then only it will get the CPU, right? Otherwise the main thread will get the CPU and everything will be executed by the main thread, right? Yes.
Yeah. Yeah.
So the CPU is a hardware or software?
Hardware.
CPU is a hardware. I mean, it runs using the software, but it's a hardware. It requires of electricity. It has the physical body, right? So the thing is, we as a Java programmer, we cannot have access to this thing, right? So this thing access will be with the OS, right? So the language will talk to it, and how the language will talk to it, that's the question. In between, there is a thread scheduler. We don't have to write the code for these things, it's already there. We cannot even change it, they are final classes. So the thread scheduler exists. So if already main thread is there, right, thread scheduler maintains a list of threads, right? So the main thread is there, right? First thing, and out of these threads, it decides which thread. If CPU, we have the CPU, right? But we have the limited CPU power. So if we have the limited CPU power, thread scheduler needs to know, let's suppose there is thread 0, right? I'm writing it T0, right? T0, T1, T2, and there can be Tn threads. Now this thread scheduler, CPU will be there, right? But CPU is limited resource, right? We cannot scale it on during the runtime. So let's suppose our CPU can only handle one process at a time. So the thread scheduler needs to make sure which thread it will give the CPU to, right? And if the thread gets the CPU, then it's going to execute, right? So it does not mean it's used. Then we need to do two things, right? Let's suppose this thread, it's not zero, right? It's not my first thread that I'm creating. Let's suppose it's the fifth thread that I'm creating. So for the fifth thread, it will be thread 4, right? Right.
Yeah.
So the first thing is, we know now the thread scheduler will be responsible to provide the CPU, right? Because it's sitting between the CPU and the threads. So first thing is, in the thread schedule, we cannot have any access. Whichever JVM we are using, you can be using Oracle's JVM, you can be using AWS, Amazon's AWS Oracle, right? So JVM. So it depends on which JVM implementer or the JVM vendor decides the algorithm the thread schedulers runs on. It can be there are multiple algorithms that exist, right? We are not going to dive deep into that. The servers we run on those same algorithm also, round robin hood, weighted robin hood. There are multiples weighted robin hood, and there are multiple algorithms, right, for the scheduling things. So load balancer uses the same techniques. So the thing is, the thread scheduler, first thing is that thread scheduler will make sure that which threads to execute, right, provided that we have the CPU. But the thing is, we need to make sure, and this thing we cannot have the access because the JVM vendor will write the algorithm for this, so we cannot change it. The only thing that we can do is we can register our thread, right? We need to make sure, right, that this is our thread. Please take T4 as a thread, right? T4 is a thread, right? So we need to register in the thread scheduler our thread T4. Right now, the life cycle of the thread we'll cover that also. What's the life cycle? What are the stages? All those things we are going to cover. So the thread's life cycle will be now maintained by it, right? And the thread scheduler, we are registering our thread to our thread scheduler. Then the thread scheduler will be responsible to provide the CPU, right? And as soon as it provides the CPU, then it start execution, right? If the thread scheduler takes back the CPU, then execution stops, right? And then again when it's provided, execution continues. Cool? Clear till now?
Yeah.
So now question arises, how to register the thread to the thread scheduler? The answer is thread.start. Okay, because it's set to begin execution, the Java must run this thread, result is to thread. Okay, it's never legal to start a thread. Okay, ये तो इंटरव्यू क्वेश्चन है, हम बाद में देखेंगे. Okay, cool. यहाँ पे नहीं लिखा, कोई नहीं, तो हमने लिखा है. Okay, so whenever we call the thread.t.start method, t is the thread over here, the JVM will search for the start method in the my thread, right? Since the my thread object is not start method. Okay, cool. Yes, this start method, right? Start method is not in our count. It's not in our counting task, right? If we have created our my thread object, we have used the way in which we are implementing the runnable, right? But we could have extended our class as well, right? The thread class directly. So the start method is of thread class, right? It's not of R. It's not R start method, right? It's of thread class. So what does this start method do? It registers the user defined thread. What is, because there are multiple threads, right? Whatever we are creating will be called as the user defined threads. So the user defined threads, it will register it into the thread scheduler. Okay, all right, and we know, right, what happens. And then as soon as it's get registered in the thread scheduler, whenever thread scheduler decides, okay, let's provide the CPU to the T4, then what will happen eventually? The run method that we have written in the overridden will get executed. It will start executing, right? Then the thread class start automatically calls the run method. to execute the logic, right? But it will be only able to execute the logic once the thread scheduler provides the CPU, right? So here are some things about the thread scheduler. That thread scheduler is a part of JVM. It decides the thread execution. Thread scheduler is a it's this normal thing that it's a you cannot expect the behavior, right? Because we'll see in the later on. Let's suppose you are T1. Let's suppose it's provide. You cannot predict the outcome of a thread. That's why this line was there. For example, not this. Yeah. For example, one thread scheduler, if you are using the thread scheduler of Oracle, then there might be a chance it gives the main thread first and then the T0 and then again T0, again T0, again T0, right? And then it provides the processor to T4. And your T1 and T2 are still waiting for the CPU. So the thing is, the algorithm they are using, we cannot work with this, or we cannot expect the output based on the algos that they have written, because we cannot see the algos that they have written, right? So to expect the output, it's almost impossible, right? We over here also, if we see the output that we were seeing, that thread 0 is executing, then thread 1 is executing, right? We have written this thing, right? Okay, let me just run this code. So right now we can just think that we are thinking that this is happening in parallel, right? This is happening in parallel, and we can even speculate what will be the output, just for the sole reason because my system is way too powerful right now, and that with comparison to the task that I'm asking out of it, right? So that's why I can make sure. But if in the real life environment where there are thousands of threads and we are using our system at their full capacity when it has the ultimate load, then this output we cannot expect this output, right? If we have two threads or even the multiple, because we are working in the multi-thread environment, there are not only two threads, there are multiple threads there, so we cannot expect the output in the same manner, right? There might be a chance in that environment, in the processing environment, we'll get 1 2 3 4 ones, and then I'll get hello 3-4 times, and then if thread scheduler provides the CPU again to the thread 0, then we'll get the 5. Or there might be a chance we'll get the hello many times and then we'll get the 5. We'll see those things, right? We are going to execute the larger number of processes and then we'll see how it's going to work, but that would be at the last end sessions. Cool. So coming back to this, so there are so these algorithms, right? Time slicing we have already seen, right? What is the time slicing? Limited times we'll give. Preemptive scheduling will be based on the highest priority task, right? Because of this only the thread will starve, right? Alright, so we come to the stages of the life cycle or the stages of the thread. Okay, so it is nothing new now. No one asked this question as well, but if someone asks, right, so that's why we need to know. And let me just write it down over here as well. If there is a single thread, or should I create another package? Okay, in basics, let me add the life cycle of a thread. Life cycle of a thread. Okay, but we need to know. Alright, cool, no worries. So the runner, and let's create a class. Let's create a class my thread, thread, and extends thread. And now I want to override. Okay, my bad. Now I want to override run method, because run method is the method from the runnable, right? So I want to execute this, and over here let's do the same task, right? I0 I less than 5 and I plus plus sys out and I plus, oh my bad, I plus 1. Alright, so this is the code, right? We wanted to know which line has which state of the thread, right? So let's start with here, and now my thread thread equals to new my thread, and then thread dot start, right? So this is the thing, right? Now we will see what will be the stages of the thread, right? So see, it's obviously very easy to know or to speculate. This thing do the okay, let me just copy paste all the stages, right? First, all right. Okay, comments are not getting auto fixed. All right, one more, cool. So new state, right? Thread is new, right? And the ready, right? When will we can say the thread is ready? When can we say the thread is ready? When
After
is
start.
Come again?
After we run start dot start.
Okay, you are saying about the line, but when it has been registered to with the thread scheduler, right? Because as soon as you provide the thread with processing power, then it will start execution, right? So as soon as it gets registered to the thread scheduler, because then it's ready. You provide the CPU or the processing power, then it will start execution. That's what we can call ready, right? So thread dot start do that thing. So this is ready, right? And before ready, we can see only one state, right? When it's created but not registered. So this would be the new, right? Making sense, right? Now the thread dot start will eventually, as soon it's the ready state, right? It's waiting in the thread scheduler that okay, please provide me the CPU. As soon as the CPU is provided, right, this method will get executed, right? So in this line, it will be in the running state, right? And then my bad. Okay, all right. So let's come back. Then running, blocked, and non-running state, right? So the sleep is also a waiting, right? For wait, there are different things, but right now I'm not using. Over here, it's waiting, sleeping, all those things it can do here. So this is in the sleeping state. So the last stage is dead state, right? When will a thread be dead? As soon as it's end with the execution of the method, right? Then there is nothing that thread has to do more. So this is the dead state. Cool. Visible? Nobody's going to ask this thing. It's usually the questions in the 2010 to 15 16 max. Now no one is asking this question. Usually people are asking this, the hibernate stages or the states, hibernate object states usually preferred, and that's more relevant question in today's era, not this one. Thread states no one is asking right now, but it's in the course, so we are going to cover it. Cool. So this thing is also we have covered. Now again coming back to the question. Now we are ready. Okay, so we know the execution already. Cool. So now I'm going to write some code. Okay, just wait, let me just check in the model what I have. In the model I have a counting task of runnable. Okay, runnable counting task will do. Cool. So now I'll write two questions, right? So one thing is registering the thread twice. All right, so this would be the one thing, right? So what I'm going to do, I'm going to just create a counting task. Okay, in the model, counting task equals to new counting task, and then the thread equals to new thread, and the task I will provide, and then thread dot start, right? So let me just run this code so that you can see the code runs successfully, right? Okay, my bad. So the counting task, it should not have this, it should be like this. Cool. So coming back to the question, I'm running it again. So now you can see 1 2 3 4 5, right? It works perfectly. Cool. It will keep on going, and it registered the thread to the thread scheduler, right? register the thread to thread scheduler, and that's what make the thread state to the ready, right? What if I try to register the same thread again? What will happen? Okay, because we have little less time. Okay, let me just add. Okay, all right, now it's fine. Okay, because we have less time, I'm just running it directly, and there will be an exception, right? Illegal thread state, because the thread was already registered and it was in the ready state. How can you make it ready again, right? Does not make sense to register the same thread twice. All right, so over here you will get illegal thread state exception. This is one interview question, right? And the interview question would be of same thing, right? So let me just copy these thing till here. Okay, no, let me just call this thing. Okay, so okay, where am I interview question. Okay, cool. So now the thing is calling error method directly. Okay, not my bad. All right, so over here what I'm going to do, I'm going to call the thread.rel. So what will be the output now? You have already seen the counting thread task, right? How will the execution flow now? I'm audible? Hello?
Yeah, yeah. It will be the same 1, 2, 3, 4, 5.
Yes, but will it run in the thread? See, usually the question in this manner, I have created only single thread, right? Counting task. So, okay, wait. So, okay, I have another task as well, right? Counting name, okay, which task? Countdown latch. Oh, I have countdown. Okay, it's concurrent. Cool, no worries. So task. Okay, I have name. Okay, I should have one more task. Let's go inside here and create another task. Okay, print name task. Let's create a print name task. It will implement, my bad, it will implement the runnable. And now we need to override this method. Okay, and over here I'll just print the name. Okay, and now I'm going to print hello, just hello user. All right, so this is my another task, and over here, so the task 1 or the name task equals to new, and then thread and print name thread equals to new thread, and in here name task should be there, and then print name task dot run, right? So over inside this also, in the print name task, I'll make sure that it wait, right? Thread dot sleep for 2 seconds, right? So what will be the output? In here also we are waiting for 2 seconds, right? So what will be the output now? One hello user, 1, 2 hello user, 3 hello user. Will this be the output now? I'm audible?
Yeah.
Okay, the thing is, it will execute parallelly, no multi-threading will happen. 1, 2, 3, 4 and 5. And the reason is have we registered the thread to the thread scheduler anywhere?
No.
And this is a normal method call. This is a normal method call. So override functionality will work. And are we overriding? Yes, we are overriding here. We overriding it otherwise also when we are running it with a thread. But right now its execution will be parallelly because the thread dot start will register the thread to the thread scheduler, then the thread scheduler will run, right? The thread will never, it's in the new state already, right? And the execution will, because over here when I call the thread dot run, no thread, this thread object is not registered to the thread scheduler, right? And the main thread is executing this line, right? So the main thread will try to overrun this method, right? But this method implementation is there, but we have already overridden the method, right? Who have overridden it? Counting task. So the counting task method will be executed, and who will be responsible to run it? Main method, right? Because main method is executing this. When we call the start, then the main method just registers the thread object to the thread scheduler and it comes back. Then the thread scheduler uses the object of the thread and then calls the run method, right? Then a new thread will start execution of the counting task, run method, overridden run method. So this is the another interview question, right? Which used to be popular. Okay. Clear till now?
Yeah.
All right. So bear with me a little more. So now we'll come back to the life cycle. Okay, ways to create thread, right? We'll come back to here, right? So this is how we were creating the thread earlier, by creating complete classes, right? But what if I want, okay, then I have to okay, cool. I have to show you how the flow goes from the anonymous class. We are going to learn the anonymous class, but not with the anonymous class. Okay. Okay, so okay, in our classes is not in our codes, but you need to know it, otherwise there will be an issue. Cool. Let me just do something with the sound. Just give 1 second. Give me just 1 second. Let's start. Cool. So see this greet. Okay, my crown thread, right? This is a class that we have created, right? Visible?
Yeah.
So, but the thing is, and what I'm doing inside this, I'm executing this thing, right? This thing I'm executing, right? Yes.
Yeah.
So there was a class. There was already a class, right? And I extended it, and I wanted to override it, one method. So I wanted to give another class a name, and then I have provided the body, right? And here is the body, right? Yes.
Yes.
But what if I don't want to use this class again? There can be two things, right? One thing can be, which is also the reason. One thing is, I don't want other people to see the overridden code that I have written, right? My counting thread is here, so anyone can see and create an object of it, right?
Okay.
Because the max security that I can provide is by removing the public, then it will become the default, right? But still in the default, my class can be accessed by other classes, right? In that package, right?
Yeah.
I don't want it. First thing, if I don't want it, what can I do? First thing, right? Another thing, if let's suppose security is not a reason, right? If anyone if want to use, they can directly use my class. I don't give a shit. But what I'm concerned is why to create so many classes, right? Let's suppose I want to overwrite it in 10,000 times. Then if I create the 10,000 classes, to maintain the class, it becomes hard, right? whatever we are writing, this packaging and those all things, right? We are writing a text, right? This is a text. This is a text, right? We we are looking it for so long that it starts making sense to us, right? But it's still a text, right? And all these packaging and all these things, we are just saving some text, right, somewhere. And we have in our brain, right, okay, that the model will hold all the classes, right? Pojos will be in the model, and the runner will execute the code. The main method will be in the main method will be in the runners, right? This thing we have created the rules, right? So that it's easy for us to navigate through. But if some normal or layman person will come, he won't be able to, right? Because he needs to read these things many times, then only he will be able to read, right? So, and again, for us also, if someone can come and write thousands of classes, then it will becomes hard for me, right, to manage it, right? Even 10 class can be, I have to go through the 10 class, right? I have to click in 10 classes to see what's happening. I'm audible?
Yeah, we should.
Yeah.
I don't want to create another class. And that's my concern. Main concern right now, right? So what can I do? Over here, what's the data is present, right? Data is present that there is a thread class, right? My counting thread is a child class, right? So if I don't want it to use again, do I need this name? I need this name just to make sure, and the package name, just to make sure that I can get to this code, right? And create this object of this class, right? But if I want to use it just once, I don't want this thing, right? I don't want this thing. I don't want the name. I don't want the package, because package and name is just to make sure that I can get to this text file, right? So the next way to write a thread is, okay, my bad, packaging. Okay, I just got a text from my office. Another task, issue production. Cool, but no worries, we'll complete this thing. Okay, battery 1%. Let me just bring my charger. Start this thing. So the next way to create a thread will be using the thread in runnable itself, but using, it's not another way, right? We are just using another technique in which we don't need to create an entire class again. It would be anonymous class, right? And in anonymous class, and everything will be same, right? So let's say in anonymous class I need to make sure that I'm running this thing, right? So what can I do in the runner itself? psvm, cool. And over here I need to run the code, right? And I want to start the counting thread. So this thing, right, we have, okay, in this runner, okay, in this thing I have run these two tasks parallelly, right? So exactly same thing, let's try to do it over here, right? So the first thing is I have created my counting thread object, right? And then start the thread, right? That's what I have done. I'm doing here, right? I'm audible?
Yeah.
So let me just copy paste these two lines and just bring to my runner over here. Cool. Now the thing is, I don't want another class root. I want to use this in the main method itself. I don't want to use it anywhere else. I have no utility of this class anywhere else inside this method, and only inside this method. Then why should I create this thing, right? So what data it's this class providing, that this is a child class of a thread, right? And overriding this thing and the name. So if I don't want to use it again, I don't need these two things, right? The name I don't want, I don't even want the package, right? These thing is just to detect the file, right? In in the folder structure. What is this package? Package is just in, you just go in the org and then batch and then comes to this multi-threading basics. This is the packaging, right? And the class name is, in the final package there are multiple files of .java, and which .java file you want to access is the class name, right? I'm audible?
Yeah.
So if I don't want to use this again, then it won't make sense for this path and this class name. So the only data I want, that okay, this is a child class of this and a method that I want to overwrite, right? So if I don't want this class to access again, and this is the body, right? This is the body, right? I can just simply go to here, and what data it's providing is, if I go inside this class, I will get the data that this is a object of a child class, right? Child class of a thread, right? Counting thread. Okay, count equals to new, okay, thread equals to new thread, right? This is how we write the code, right? But what if instead of ending it, I provide the body directly? I have provided the body directly, but I get extra. Okay, why the counting dot started inside this? It should be outside here. Okay, methods ends here, class ends here. I need one more this, and end it. Cool. Now this will be called anonymous class. Visible?
Yeah.
So what happened? I don't want this code, this body I don't require anywhere else, right? So I can just copy paste it directly. What data this class was providing me, it was just saying that okay, your class is a child class of a thread, right? Now I know that okay, I'm using a thread object, right? And then the body, in this thing I'm providing the implementation that I'm overriding a single method inside this. So if I'm registering the thread also, right, to the thread scheduler. If I run the code, 1 2 3 4 5 will be parallelly executed, and in this thing I can even make sure, you can still doubt, right, that the thread is not executing this thing. But what I can do over here, thread dot current thread dot get name, simply I can write this thing. See, I will suggest you to, okay, 01 y 01, okay, 02, okay, my bad. So space is required before these two, right? Otherwise it will be way too close. All right, just run this again. Thread 0, thread 1, right? Not the main thread, right? So it's properly thread working. Visual?
Yes.
All right. So the thing is, till here we have seen, right? Everything is same. So this was the anonymous class way, right? Till Java 5 we used to write code in this manner. But later on what happened? Lambda. Alright. Same thing. I'm going to take entire class. I'm going to take. Where is lambda? Lambda. Right. So the Java people usually think, right, what we can remove. So earlier, if we want to use once in the anonymous class, we have seen that why we don't need, right? We don't need the class if we want to use it in the single time, right? We don't need to have the class name, right? So we have removed that, and the entire body we can make sure we can write in a single line itself, right? So the entire data that we wanted, we have it, right? So but what extra do we have right now? So let me just run it first in the anonymous lambda area, right? So see, same code is running, right, properly, right? Visible? It's running fine.
Yes.
So what redundant data that we are seeing over here? Oh, my bad. Okay, my bad. Okay, cool. Now it's good. So what redundant data is there in this code right now? the one thing that we can directly see, the thread is already over here, right? So why to mention the thread here also, right? It will be an object of thread here if okay. So this, see, my thread equals to new my thread, right? So this is the constructor, right? This is the constructor that I'm going to use. But the thing is, over here, do I want to again make sure that okay, I'm writing this thing again, right? If there is a constructor and I don't want to use some parameterized constructor, right? Then this thing should not be mandatory, right? It can be directly initialized, right? Over here, writing thread again over here, will it make sense? Because the object will be of thread only, right? If I want the object of the thread, if I want some child class object, then the parent class holding the child class, then it's a different thing. But if I want the object of the same class, isn't it redundant data? And if I want a thread, obviously I want space, right? I'm audible.
Yes. Yeah.
So, and then I want to call the constructor, right? But constructor calling is mandatory, right? So I can remove this thing, but just to find the constructor, I can leave this thing, right? If I wanted to call integer, then I can write 10 and 2, right? So, and then this thing is provided, right? Just to make sure that after the constructor, this is the implementation, right? Now inside the implementation, okay, all right. So now the thing is, we have seen this much, right? Do we have some other redundant data right now with us? Can we remove something more from here? Okay. So if I just remove this and this, then something more needs to be removed. But what's the thing? What's the thing that you can say that okay, this thing is not making sense over here, or what more can we do to make sure that it's good? Okay, let me just write it down, put it back, right, in the state that it was earlier, right? So this was the state, right? When I copy pasted it, oh, okay, oh shit, we are in the, oh, we were making changes in the anonymous class. My bad. Okay, let's just put it back the way it was. Okay, cool. We don't have to make changes in the anonymous class runner. Okay. All right, thread. Okay, now it's fine. Cool. Let me just try running it. Cool, it's working fine. Great. We need to make change in the, okay, I haven't just copy pasted. Cool, my bad. All right, cool, no worries. Okay, all right, but the thing is, okay, this is the way, right? What's the extra data that I am having? One thing is the constructor call, right? Now I want the body, right? I'm audible?
Yeah.
See, the Java, when I try to copy paste the code, the Java itself provided. Why I am coming back to the anonymous class? It's not making sense. Again, I'm at the anonymous class runner, but okay. Wow. All right. Let me. Okay, in the lambda. Now we are in the lambda. Cool. All right. Yes. So over here, this constructor is not. We don't want this thing, right? Only the constructor can work, right? after it what other data is there that we can remove. This is for the constructor, right? Thread equals to new thread we were using, right? Over here, see, thread equals to new thread, right? So we don't want this thing, because by only computing this thing we can know, okay, the zero hour constructor of this thread class we are trying to use, right? All right, and then these two, right? Why is showing error? Because these are not allowed here, so we remove this thing, right? Directly we just wanted to make sure that a thread object is created here, and we want to override it. The child class, we want to make sure that we can create a child class. So both annotations not allowed, or a single annotation not allowed. There is an issue, right? Am I audible?
Yes.
In interfaces we have seen one thing that we call functional interfaces. Remember? What's the definition of function interface?
It has only one function.
One abstract method. We don't call functions in Java, we call them methods. And if we have only one abstract method, right? Any number of concrete methods, but only one abstract method, right? Then it become functional interface, right? Now the thing is, how we create a thread. If we want to use runnable, so runnable object, right now we are using the thread object, right? But we also use, okay, instead of writing this thing in this manner, we can thread equals to new thread, and we can pass, okay, we can call it counting thread, right? I have taken the example of that thing, and over here, instead of this, if I take the runnable object, see, the thing will be same, right? The runnable object, we need to pass it here. In the normal scenario, in the ways to create thread, in implement runnable, we were creating a runnable object, okay, implement runnable, right? And then we were passing it to the thread object, because thread has a constructor which takes the runnable object, and then we were registering, right? This thing is same, creating the thread and calling the thread dot start, right? So over here also, in the lambda runner also, we want to create over here. Now what the thing is, if we are going to write in this manner, now we know that in the run method we want to override a single method, right? Because it force the runnable interface will force us to implement the method if you want to create a concrete class, right? And we want to create an object. If you want to create an object, that means we want to create a class also, right? So object can be created from a class, right? So if I'm using runnable, then it will force us, any class, if I want to implement the runnable to create a concrete class, and it will force me to provide the body for the run method, right? Am I audible?
Yes. Yes.
So if it's going to force me to write the body of this thing, runnable method, right? But with the runnable method, because it has only a single method, right? No more method. Am I audible?
Yeah.
If it has only a single method, so I don't even have to mention it, right? Because I have to provide a body of a single method. I can even define more methods, but the thing is, if I'll define more methods, can I use it with the runnable object? We are creating a child class over here, right? This thing is clear to you guys, right?
Yeah.
So if I create a child class, and child class will have multiple methods, more methods, if my child class has more methods, will by using the parent class reference variable, will I be able to use those methods if the child class has more methods than the parent class? Alright, that's why basics are important. If my parent class has a method m1, right, and my child class extends the parent class, so the parent child class will also have m1 and m1, right? If my child class has m2 method again, and if I create, okay, let me just write it, you will remember. Maybe a has m1 method only, cool, and b has m2 method, but b extends a, cool. And then if I create an object, of a equals to new b, can I do a dot m2? Will it work?
No,
Why?
because by reference,
You can only call those methods which
A
will be in the class of the reference variable. So a class has only m1 method, so you cannot call m2, even though the object has the m2, but reference variable does not have the m2, right? So the thing is, the the basics are important, right? Then it will become easier to understand the other concepts. So over here, if you try to override more methods also, you won't be able to access it, right, with this runnable, because runnable has only one method. You will be able to use only runnable method only directly. So if you try to write it, override it, then too you won't be able to write it again. You won't be able to access it using the runnable object, right? Runnable will have only run method, and that's it. You won't be able to use any other method apart from run using the runnable object. And if I pass it directly to it, now you will see. Okay. See, with the wrong thing with the lambda, the drawback with the lambda is exception handling. You need to provide the try catch. You cannot even throw, right? There is no method name, right? So how will you delegate the responsibility to the caller method? So lambdas has this drawback. You don't have to know it right now, but it's completely cool. See, if I write over thread.sleep, then 20 seconds, 2 seconds, I don't have any other option other than writing the try catch. So right now I can do it if you want to see, but it becomes the code a little bit untidy, especially if we are working with the multi-threading. People already are unable to understand many concepts, and this exception handling made it a little more complex, right? So we can directly remove it. But we know, right, the thread name is there, so we know the thread has executed this lines, right? Clear till now?
okay.
Yeah.
See, if you are having a little doubt regarding this thing, this lambda, right, I have skipped one part. Otherwise we will go into the anonymous class and in the flow that we usually go from. So if you wanted to know a little bit more, uh, 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 so lambda we want even, if we are if you want to write more than this thing, right, if you want to overwrite more things, then we need to go to the anonymous class. But if we have, we can use the lambda, we can use this thing, right? The way that I have written it can be only be written if my function is, if my interface is functional interface. The reason if there are multiple methods, then abstract methods, then how will I know that which abstract method I'm providing the body, right? Cause the runnable interface has only a single method. So whatever body I'm providing, whatever data I'm providing will be to override that method itself, right?
Yeah.
So it can be used with only function interface. Otherwise we cannot use this thing direct without the method names. Cool. We will cover this in the later sessions also. All right, so I'll